Hey QED coders, this is Michael. I'm a director of consulting at Improving, so give us a call if you need some help setting up something like this. So we are building an example of a Jinaga mesh, a bunch of components that are all working together. And we're simulating a university system. So far we've added a few components, and I wanted to see a little bit better what's happening inside of those components. And so today we're adding some observability. Let me start by showing you the mesh as we currently have it built out. So you can see right here in the middle, we've got our Jinaga replicator. This is our upstream replicator that these two importer and indexer functions connect to. So the importer function is going to read some data from a folder and then create those facts and send those to the replicator. The indexer function is going to subscribe to a specification, so it'll receive some of those facts, just the ones that match that specification. And then it'll turn those into a projection and then store that projection in Elasticsearch. So this is simulating the part of the university system where we are dumping a whole bunch of offerings into a folder and then bringing those into the system so that they can be indexed for students to search that index and then register for those courses. So in order for us to build this out, we want to lay out everything in Docker Compose. So let me take you over to Docker Compose and show you around. So there's a lot going on in here. You can see that we've got our Elasticsearch container right here at the top. And then here's our backend replicator. That's the one and only replicator that we saw in that diagram. The front-end replicator is coming later. Then we've got our importer and our indexer, the two console applications that we're building. And so we've provided the Docker files so that we can build those. And so we build those, we set them up, and we get things off and running. And now here you can see that we are bringing in some additional components. We're bringing in the Open Telemetry collector. And then we're bringing in these crazy named things: Jaeger, Prometheus, Loki, Grafana. What's that all about? Well, those are our observability tools, and they're all using Open Telemetry in order to show us what's happening inside of our system. So I want to spin this up, and I want to show you Open Telemetry in action, collecting all of this data for observability. So I have pulled the repository. I'll show you where you can get the repository yourself. Go to github.com/jinaga/university-system. And then from here, you will be able to follow along as we build out this example. One of the things that you can follow along with is this Polyglot notebook. Oh, definitely want to install the extension, but here's the link to the notebook itself. And this explains the entire model. It explains the model by building it out and drawing graphs. This is one of my favorite parts of Jinaga, is that I've got this Jinaga notebooks package that uses GraphViz in order to draw these graphs of your model. You've seen these on the channel before. So these are really, really fun and informative. So check all that out here. And then you'll also find instructions for how to run the system. So let's go ahead and do this. We're going to go into the mesh folder. And we are going to Docker Compose pull in order to get the latest versions of all of these, all of the images inside of these containers. So you can see that it's already pulled Elasticsearch. Now it's working on Jaeger and Loki and the Open Telemetry collector and Prometheus and Grafana. Apparently I need to pull a new version of the backend replicator. I guess I've modified that since the last time I was on this machine. But it's going to pull all those images, and then we can start to build those containers based on those images that we saw inside of that Docker Compose file. All right, we've got those all. And now we can do this Docker Compose up -D to disconnect, and then --build. The reason that for the --build is that the importer and indexer are Docker images that we build ourselves using a Docker file. And so the Docker compose just points to that Docker file. This tells it to go ahead and build those images. So you can see it running through all of those steps on both of those images. And it's building the C# .NET applications, and then it's doing a .NET package, and then spitting those up inside of a .NET publish. There we go. And then it's spitting those up inside of there we go, a runtime, .NET runtime image. So yeah, we built both of those. We have created a network and a few volumes, and then we have started all of these containers. So all of that should now be running. Let's take a look at Docker Desktop and see all of that wonderful work. So here's the university mesh. We've got our index and our importer. Here is our backend replicator connecting those two together, and here's Elasticsearch. And then the rest of these are all observability things. So let's talk about observability, and specifically about Open Telemetry. So I'm going to start with this tool, Jaeger. Jaeger is an Open Telemetry visualizer for traces. That's the thing that it looks at. What is a trace? Well, let's take a look at the importer, and let's see, that looks too big. There we go. And find all the traces there. A trace is one of these things, a timeline. You've seen these inside of your browser developer tools. So when we've got a whole bunch of things happening, you will see all of these bars showing parts of what's happening here. All those bars are called spans. So this trace just has one span in it. The importer did a whole bunch of stuff here. We can drill in and see exactly what it did. It called Jinaga/save. And eventually I will have Open Telemetry plumbed into Jinaga, and then we would be able to see the spans of what happened inside of the Jinaga replicator to do the save. Don't have that turned on yet, but that's going to be very important. So that's Jaeger. That is traces. Let's go ahead and run this thing, and then we can actually see some of these traces get generated. So I am going to grab my university data. This is a big old CSV of all sorts of course offerings from different semesters. So we've got our summer 2022 semester, but we've also got fall 2023, fall of 22, etc. And that we want to import. So we're going to just drag it into the import folder here. We've also got a processed folder and an error folder. And the importer is going to see that, pick it up, import all that data, turn it into facts, and then when it's done, it moves it into processed. Moves it into processed. Into processed. There it goes. Wow, that took longer than I expected it to. So now just to keep everything nice and clean, I'm going to move it back to data. And I get that permission denied thing again. Okay, I have to figure that out. Okay, we'll leave it in processed for right now. Okay, so what happened? Let's go ahead and find traces, and now we can see all these different traces. So there's our time going across the bottom, and then we've got the duration of all these different traces. And so, yeah, you can see some of them took a long time, some of them were really fast. Let's take a look at this one here. This one took the longest, so we can see, oh, that is what it took to do all of that work. So we're in the university importer, we're creating some facts, and so it's got to make all these different calls. It's doing posts and gets and what have you. And so this is going to post to Jinaga save. That one is probably going to post to Jinaga feeds. Yes, I want to get some feeds, and now let's go ahead and get from one of those feeds. So here's the Jinaga feeds, and there's that particular feed address. I'm going to pull that. Meanwhile, I'm going to pull a different feed. So you can see these are two different feeds, and if you take a look at them side by side, collapse these all back down, you'll see that it's doing these gets simultaneously. So it's pulling from all those different feeds simultaneously. So this is exactly the same kind of stuff that we could see in the browser when we were using Jinaga.js in order to to build a React application. So same kind of stuff, but now you can see it in the microservices running in your application. So that is traces, and that's pretty darn cool. Now, what else do we have? So in addition to traces in telemetry, we can also look at the logs in Grafana. So here we're going to go to localhost 3000, or if you're in here, you can go to Grafana, click on the 3000 there. That'll take you in there. The username and password is admin. I know it's compromised, and I don't want to change it, so skip. Now that we are in Grafana, we need to connect this. This is just a visualizer. It doesn't store the actual logs. Grafana is for logs. So we need to add a data source. We can do that by clicking over here, or we can go to connections, data sources. Either way. And then add a data source. These are all the different data sources that I could use. I am going to use Loki. I have installed Loki in order to gather up all the data and store it. So that Loki address is going to be HTTP Loki, not localhost, 3100. The instructions for that are right here. So there's your address for Loki. Save it, test it, connection's good, and now we can explore. So we can take a look at all of the logs that we've collected. So let's go ahead and take a look at the service name. Let's look at the importer. There's the importer. Okay. All right. Add the JSON parser. All right. Now add a label filter. So I'm going to look for the label. Well, actually, I don't want a label filter. I just want to show the stuff. So let's run the query. Come on. That's not right. There we go. There's some logs. Okay. I still have to practice with this tool. Okay, so we've got a whole bunch of logs going on in here. If you take a look at the body, you'll be able to see some interesting stuff there. So we should be able to say I want to show this field instead of the message. Boom. And now it's a little bit easier to read. It looks a bit more like a log. So we can see all that stuff going on. There's Grafana. This is going to help us to diagnose problems. As you can see, so far no problems. Everything's green. That's because everything is an info. Somewhere in here is an info. There's a log level info. All right. That's great. So we've got that query. Let's go ahead and save that query. Can I save that query somewhere? Well, we'll just hold this open. We'll hit that button later. Traces, logs. What else have we got? We've got metrics. So the third piece of this is to view metrics in Prometheus. So here's localhost 9090, or you can come over here to Prometheus, click on 9090. You're inside of Prometheus, and then I've got a few things that we could try. Let's look at the rows process. That's more interesting. So let's run the rows processed, execute that, and Let's see. Oh, wait, I've got that set to the 5 minutes. I've probably been yapping for more than that. Let's go for 30 minutes. Execute that. Okay. I'm not very good with this tool yet either. Rows, processed total. Just show me the number. There we go. Okay. I thought I would just see one number, but I'm seeing... Okay. I definitely need to figure out this tool. Okay. We'll be using Prometheus a little bit later when we're trying to increase the throughput, make sure that we can measure everything. But for right now, we'll go ahead and put that on the back burner. We're going to be looking at logs in order to find the problems. We're going to be looking at traces in order to see what's really going on under the covers. So those are the 3 aspects of Open Telemetry, and they're all built into this Docker Compose so that we can see what's going on. Now, let's take a look at what this code is doing. So if I dive into the code, we've got the importer, we've got the indexer, and we've got the model and some common stuff. So the importer, we just kind of observe that taking this CSV and pulling that in. Here's the indexer. It has, inside of its little program, it has these 4 services. I'm going to index offers. So there's my offer index service. I'm going to update the time of offers. So here's my offer time update service. I'm going to also update the location and the instructor of offers. Let's dive into these one at a time, see what they look like real quick. So each one of these, once we start it, we are going to create a specification. So let's kind of walk through that specification. We're going to start from a semester. So given a semester, find all of the offerings that are successors of that semester, offering semester. That's how you get to just that one little hop. And then you just want to filter those offerings down to where there are no offering deletes and there are no search index records. And then select those offerings. That's kind of hard to visualize. Well, that's why we have the handy dandy notebook. Let's go to the notebook. Here we are. And you can look at it inside the browser, or you can open it inside of Visual Studio Code and run it yourself. But let's take a look at an offering. So inside of a semester, we'll have offerings for courses. And the offerings will have time. You see the little loop prior, that's your clue that this is a mutable property. Here's the offering location. And then here's the offering instructor. Now that's just a pointer to the actual university instructor. So there's the person. There is the fact that this person is teaching this offering. Then we have this university offering delete. So if this exists, then that means that offering has been deleted. So the first thing that we're looking for here are offerings where there are no offering delete. So these offerings have not been deleted. Now let's look for this next one, the search index record. It doesn't show up on this diagram here. Instead, we need to scan down a bit more. So we are setting up some offerings, and then we want to run the application. So we've got the student portal, we've got the course search index. This is really the area where we need to be. Yeah, so this is actually the diagram I was looking for. So here's our university offering. Remember from the other diagram, it also had an offering delete, instructor, location, all that stuff. But we're not showing that here. We're just focusing on the search index record. So this search index record means that I have written this to the database. So to Elasticsearch. So when I write it to Elasticsearch, what I'm going to do is create a search index record with this particular record ID. The GUID that was used in order to create that record for that offering, and record that as a successor. And so that's what this is doing. It's looking for those offerings that have not yet been indexed. So if the offering is not deleted and not indexed, it needs to be indexed. So how are we going to index it? Now we're going to subscribe to that specification, and then every time we see an offering, then we are going to compute the hash, use the hash as the record ID. This is a change from what was in the model. In the model we used a GUID, but now we're using the hash of the offering. That keeps it consistent and deterministic, which is nice. And then we are going, and yeah, here we're making it URL safe. So get rid of all that stuff. Just makes it easier to copy something and then turn that into a, paste that into a browser and see something in Elasticsearch. Elasticsearch does not need this to be URL safe. It's just a convenience for me. So we create that search index record, and then we index it in Elasticsearch. And if that succeeded, then we create that search index record fact. This, by the way, is Open Telemetry. We're counting up the number of offerings that were indexed. That way we can see that number. So that is what the offer index service does. It basically finds offers, creates search index records. So let's hold on to that one for a moment, and then let's take a look at the offer time update service. So you'll see this follows the same kind of pattern, dependency injection, and then start creates a specification, and then subscribes to that specification in order to do stuff with Elasticsearch. When it's done, this is going to create a search index record time update. Let's see if we can find that. So here's our university offering. Here's our search index record. And now if we've got a university offering time and a search index record, then hey, given those two things, I can create a search index record time update. Basically, recording the fact that I have updated Elasticsearch, that particular record, to this value. So that's recording that I have done the appropriate work. Do I have an instance in here? I don't think I've got instances of those in here. No, just demonstrating it actually working. But in here, let's take a look at what we are doing with this. Let's look at this specification, which is getting a little bit more hairy. But you'll see that search index record time update right there inside of the specification, where that thing does not exist, where not any. So that where not any is the part that turns this specification into a queue. So if this specification fires, it's because there is work to be done. What's the work that needs to be done? Well, first of all, we're going to look for an offering where, in this given semester, where there does not exist an offering delete. Cool. So we just have the ones that still exist. And then we're going to look for time in that where that time offering is equal to that offering, and then look for those which don't have an offering time next. So they haven't been superseded by another record, another time. Haven't changed the time. Then, with all of that, I'm going to go ahead and get the record from the offering. So that search index record that I created in that first service. Let's go ahead and grab that too. So now at this point, I flip over here. I have a search index record. I have a university offering time. Now let's see, do I have a search index record time update that points to both of those, where there is not any update in successors of type search index time record time update, that the update points to the record and the update points to the time. So if that thing does not exist, it needs to. There's work to be done. So let's grab that record. Let's grab that time. And then let's do that work of updating the record time and then recording that fact. So this updates Elasticsearch. If it's successful, it puts that success into the model, hence removing it from this work to be done. Now that thing exists, and this specification will no longer return it. Okay, that is the queue pattern at work. And so coming back here, not there. Coming back here, there it is. We can see that we have built these little tiny machines into this indexer function. This is the one that we're looking at up here. This indexer function is made up of these 4 machines. One does offer index. One does offer time update. The other one does location update, and the other one does instructor update. And these look exactly the same as time update. So these little tiny machines are built into this microservice, and they all look the same. And that is the way that you will compose microservices using Jinaga. The really cool thing is, at least right now, the way that we've got these implemented, these things don't even need to live in the same process. They are just looking at facts and doing their thing. Now, when we get around to fixing a problem that's happening, then it'll be a good thing that these are in the same process. We'll correct that. All right. So what is this problem that's happening? It looks like everything is working just fine. Let's get back here to our logs. We can see everything's being imported into the replicator just fine. Oh, let's see. We haven't looked at the indexer yet. So let's go over here to University Indexer, run that query, and see what's going on. So again, let me expand this. Let me set the, let's see, here's the body. Set the visible field to body. Now we can see, all right, so we are updating, let's see. We are updating a whole bunch of things. Ah, here we go. We are starting to fail. Good. So, failed to update instructor for this course. Why is that? Why did I fail to update the instructor? This isn't saying. In order to find out, I actually have to go to Elasticsearch and see what problems it's having. But yeah, you'll see kind of a pattern. Is that here I'm trying to update instructor and time for the same course. I've got that same hash right here. I'm trying to update this record twice at the same time. The pattern that you start to see when you kind of look into this is that it's going to insert a record and then immediately try to update it 3 times because it's got an instructor, it's got a time, and it's got a location. And all 3 of those are controlled by these 3 separate little tiny machines. So that little tiny machine right here is going to pop some work off of a queue and then call right here. It's going to call update record time. So yeah, inside of this is calling update async on our little Elasticsearch client and setting days and time for this offerings index. Yeah, you can see that the index record, that's calling index async on that thing. But yeah, here we're updating location. Here we are updating instructor. But always on the same record. So what this is revealing is that Elasticsearch doesn't really like to be treated that way. It's going to grab the data, it's going to store the data, but Elasticsearch does 2 things. It stores data and it indexes it. So it's going to store the data, it's going to get right back to you, and meanwhile it's indexing it. And if you send another request in for that same row before it's done with indexing, it's going to say no, reject, hold off, let me get finished, and then you can tell me. So that means that when we were here, this came back as false, and we said, okay, we can't capture this fact that it was updated. This time was not updated. This instructor was not updated. But subscribe is really just telling us about all the things in the queue, and then if something new matches that specification, it's going to tell us about that too. But it's going to tell us about each one of those once, because that's kind of the contract of subscribe. Tell me about everything, but only once. And so if I were to restart this application, create a new subscription, now this offering, this specification is going to find those offerings that need to be indexed, that need to be updated, because this search index record time update doesn't exist. So let's see that happen. Let's see that happen. So I'm going to go to the indexer. I'm going to stop the indexer, and I'm going to start it back up again. It's going to do its indexing thing, and then I should be able to see more stuff going on. So we can see this, press Control-C to exit. That happened again. Yeah, we can see the, time is going in the opposite direction. 54, yeah, 52, right. Yeah, so I think we need to rerun the query, because I've been yapping for a long time. Here we go. Run the query again, and now, yeah, we jump from 2054. Now here we go. We are now at 2117. So we have restarted. So starting it up, press Control-C to exit, and now here we've updated the time. We've updated the instructor. So now everything should be up to date. Now I'm curious. This is going to bug me until I figure this out, but I'm curious why we're only seeing these two and not these. If we failed to update the instructor, we should see that we're updating the instructor. We should see that 2 more times. Let's just run the query again just to see. No, didn't happen. Okay. I am very curious why that didn't happen. Let me restart the indexer again. Boom. Boom. And run the query. We have started the indexer. We're waiting to exit. Yeah. I think this error occurred while running the application is really just the SIG term, just the shutdown. So I think that's fine. I should probably change the log to say shutting down. Okay. Yeah. I am very curious why we didn't see that that come through a second time. But so there is one of the problems that that we are seeing. So what's the solution? Let's talk about the solution. The solution is that these 4 pieces of work need to somehow coordinate with one another. So I can't just spam Elasticsearch every time I have work to do. It's like, I got work to do. Boom. Instead, what I want to do is I want to collect that work into some buffer. So this guy says, hey, I've got a new record. So here we go. Put that record into the buffer. But don't mark it as completed, because it didn't actually happen yet. It's just in the buffer. And then, meanwhile, this guy will come through and he'll say, I've got some work to do too. Now, this guy actually looks for the search index record right now. So that part of the specification might need to change. So we will reason through that when we get to doing that. But we look for the work to do to update records, and we'll have to figure out, have they already been indexed, or are they yet to be indexed and they're just inside of this little work buffer. So it's going to look through the work buffer, find the object that this guy put in there that says I need to index that, and it says, okay, you need to index it and you need to update it. Let's combine those. And then this one will fire, and then this one will fire, and those four will combine into one Voltron object that says I'm just going to index this record complete with all of its properties. And then once it indexes it, it will come through and it will create. It'll create this thing, and it'll create this thing. It'll capture all of that history that these things happened. So that way we can be gentle on Elasticsearch. We can use Elasticsearch the way that it's intended to be used, instead of just smacking it every time we've got work to do. So that should greatly improve things. Now, there's one last thing that I want to try real quick before we sign off, and that is if we come back to these traces, you'll see all these little hits. I'm calling a whole bunch of stuff on the replicator. I think I can do better than this. I think what I can do is I can kind of queue things up inside of the application, the function. This is the importer function. I can queue things up there and then blast a whole bunch of things to the replicator all at once. So the way that I would do that is that I would turn on a local replica inside of my application. So let's see if this works. I have not tried this yet. But we're in our Jinaga client, and we're creating a Jinaga client using this HTTP endpoint to point to the replicator. But there's another library that I could bring in. Let's go ahead and go to source, and this is University Indexer, and I'm going to do a .NET add package Jinaga store SQLite. Ba-ba-ba-boom. Okay, so now I have SQLite as a library in here. So you can see here I've added Jinaga store SQLite. So just to prove it, that is a brand new package. And so now I should be able to use Jinaga let's bring in the namespace. So I want to using Jinaga store SQLite. And now I have access to Jinaga SQLite client. Boom, there we go. So we're going to create a Jinaga SQLite client. Same options for HTTP endpoint, but now I also have options for a SQLite path. So let's do that as system IO path combine. Let's see what we generated here. So I want the special folder for local application data. Then I want University Indexer. Then I want JinagaDB. Perfect. So let's use that SQLite database and see if this behavior is any better. Oh, but this is the indexer. I wanted to look at the importer. Let's see. And let's also take a look at indexer, find those traces. Take a look at, yeah, these traces are not all that interesting. So yeah, it's the importer that I really want to look at. So let's go to the importer and do the same thing. So cd university, come on, cd university importer. I don't know why I wasn't getting completion help there. Now I want to do a .NET add package, Jinaga store SQLite. And then let's come over to the program for the importer. And you can see it's got the same basic structure. Where's that? Where is that thing? Console app. Oh yeah, it's inside of the console app. There. No, it's not. We're creating a client here. Okay, there's the Jinaga client factory. So Jinaga client factory, create client. There we go. So rather than using Jinaga client, I'm going to use Jinaga SQLite client. Boom. And then let's do the same thing. Options SQLite path is boom, university. Nope, that's not right. Compare that with that university indexer, JinagaDB, university.importer, JinagaDB. Yeah, boom. Even though they're completely separate processes and separate containers, I'm still giving them different folder names. All right. Now we've got some new stuff. I want to test that out. I want to see what difference does it make for this thing to be using SQLite. Okay. So I'm going to go to here, and I'm going to do a docker compose down, and then I'll do a -v, and that's going to delete these volumes here that were created. If I don't do a -v, then it will keep these volumes around, and I can still look back at all of this, all the logs from previous runs. I can look back at the previous, actually, yeah, the spans, the traces are not stored. Jaeger, I haven't got it configured for storage, but the important things are this this Elasticsearch data and the volume that is backing the replicator. So this backend replicator has a volume. It's not named here, but I want to make sure that we clear that out too. So compose down, delete all the volumes. So it stops all the containers. And then removes the volumes. And we are all good. So now we can Docker compose up with build. And now that the source code has changed, it's going to do a rebuild. So it's going to create some new containers for me, some new images, and then new containers for those images. And it's going to create new volumes and all that fun stuff. Which means I would have to set up that connection to Loki again if I wanted to use Grafana to look for errors. But I'll do that later. For right now, I'm just looking to see what behavior changed with respect to the traces. Okay, So now I want to get rid of these. I want to get rid of this university data here and restore this one. Let's see if I can do a restore on that. Yes, I can. Can I get rid of this? I cannot. But what I can do, get status, I can see let me do a diff name only, and now I can see, it's not there. This data processed. This data processed university data. Okay, so I want to sudo rm data processed university data. And now, if I type the password correctly, I can delete that. Okay, now that's gone. Okay. Here we are. So we've got our university data. We can drop it here. Everything is running. Let's see everything running over here in the containers. Everything is running here. Oh, these two did not start. Why did they not start? Any clue in here? Oh, yeah, it was trying to process the file. Yeah. Okay, you know what? I'm not certain if it was able to get something done with those files before it crashed. So, let's do a nice clean. Let's do a clean run. I don't want to be tainted by guessing at what happened there. But now, those files are out of the way. Should be able to take everything down. And bring everything back up. Nothing has changed, so those builds went really fast. And now everything should be running. Oh, wow. They still failed. Okay. The file app university importer already exists. Okay. Well, we found another bug. Excellent. So I've got some work to do on this one. This is actually not to do with the CSV file like I thought. This is to do with the SQLite file. So it is trying to create that path for the SQLite file, and the path already exists. Which is weird because it should have just checked to see if the path exists and create it if it doesn't. But, okay, so we will get that fixed, and then we'll be able to use SQLite inside of a container and see how that changes things. And then we will also come back and we will see what we can do in order to change the strange little behavior that I can no longer see because all that data is gone. That we were hitting the we were hitting Elasticsearch over and over again. That was actually in the logs, not in traces. And the failures in sending to Elasticsearch. And then hopefully, once these two problems are fixed, we can then see the other problem that lies at the end of this rainbow, and that is that the replicator is getting a uniqueness constraint violation. So that's going to be a fun one to fix too. So come on back next week and let's see what we can get fixed. I'll see you then.